Okay, this video is going to look at the technique for factorising a cubic, which is what you would need to do if you wanted to try and find the solutions to a cubic equal to 0. Now, just like we have a quadratic formula, there's also a cubic formula that exists, but it's long, it's unwieldy, it's not easy to use. So if we can, I'm not saying that you always can, but if you can, it's better to try and factorise it where possible. So we're going to take this particular example of factorising this polynomial, x cubed plus 2x squared minus 29x plus 42. And it's going to rely on something called the factor theorem. And the factor theorem tells us that if we put a value x equal to a into this equation, and it's equal, and then the answer that we get is equal to 0, then x minus a is a factor. The factor theorem is actually a special case of a more general theorem called the remainder theorem, which you probably have studied as well. Now let's think, if we fully factorize this, then it's going to look like x plus a, x plus b, x plus c. Now if we were to multiply out what I've just written there, you would have a variety of different terms, but you would have finally a constant term, which would be the a times the b times the c from each bracket. And that would correspond to this number 42 here. So if we want to try and find these values of a, b, and c, then the best thing to do is think about the factors of 42, okay, because they must multiply together to give 42. So let's list them. What numbers go into 42? Well, we've got 1, 2, 3, 6, 7, 14, 21, and 42 are all the different possibilities. And because we've got three things multiplied together, two of those could be negative and it would still give you the positive answer. So you could have plus or minus of each of these. Okay, I'm not going to write plus or minus in front of everyone. So these would be the values that you may try first. So let's go with the simplest value. Let's try and evaluate this when x is equal to 1. So we put x equals 1 into that cubic. So we get 1 cubed plus 2 times 1 squared minus 29 times 1 and then plus 42. What does that equal? Well, 1 plus 2 plus 42 makes 45 minus 29 is 16. Okay, and that's not equal to 0. So that value was no good. Nice try, but didn't get us anywhere. Okay, let's try 2. Now it's trial and error, so we've got to just keep trying values until we find one. But let's try 2 next. 2 cubed plus 2 times 2 squared minus 29 times 2 plus 42. So that's 8 plus 8 minus 58 and then plus 42. And if we put that all together, 16 minus 58 is minus 42 and then plus 42, well, that's 0. Great. That's what we've been looking for. So therefore, we can say that x minus 2 is a factor. And that's great news, because if we take that out as a factor, we're just going to be, of the cubic, we're just going to be left with a quadratic. So there are two approaches, and I'll go through both of them because they're both useful techniques to know. So one way to do this is we could do polynomial long division. So we could divide the cubic by the factor that we've just found. And what we should be left with up on the top here, which we call the quotient, should be a quadratic. So let's have a look. So what we do with polynomial long division is we look at the leading order term in the polynomial, which is x cubed, and then we look at the leading order term in the divisor, which is x, and we see how many times does x go into x cubed. So x cubed divided by x, that's x squared. And then we multiply that x squared by the divisor. So we get x cubed minus 2x squared. and then we subtract. So 2x squared minus 2x squared, so that's plus, that gives us 4x squared, and then the other two terms, just bring those down because we're subtracting 0 from those columns. And then we repeat the process. How many times does x go into 4x squared now? It goes in 4x times. And then we multiply that 4x by the divisor. So 4x times x is 4x squared. 4x times minus 2 is minus 8x. And subtract. Minus 29 minus 8 is the same as plus 8. So minus 29 plus 8 is minus 21x. And then the 42 comes down. How many times does x go into minus 21? X, it goes in minus 21 times. And what we should also get is no remainder. Okay, because it's a factor, there shouldn't be anything left over. Okay, so that's one way of doing it. Another way to do this is to write, we know that the cubic is going to be equal to the factor that we found multiplied by some quadratic. So we'll just write down the most general quadratic that we can and then multiply all of that out. So I'm going to have ax cubed plus bx squared plus cx minus 2ax squared minus 2bx minus 2c. So I've just multiplied those two brackets together. And now what I do is I compare coefficients. So I say, how many x cubes do I have on the left hand side? Well, I've just got one of those. How many do I have on the right hand side? I've got a of those. So I'm looking at the x cubed coefficients on both sides of the equation, which must be equal. So I can say that a is equal to 1. Then I look at the x squared terms. How many x squareds do I have on the left hand side? I've got 2 of them. How many x squareds do I have on the right hand side? Well, I've got b there, and then I've got minus 2a here. So I can say 2 on the left hand side, b minus 2a on the right hand side. So b is equal to 2 plus 2a, and I know that a is 1, so this is 2 plus 2 times 1, 4. And finally the x term, I've got minus 29 of those on the left. On the right, I've got c minus 2b. So c is equal to minus 29 plus 2b. So minus 29 plus 8, which is minus 21. Okay, so I get the same coefficients as I had before. So ax squared plus bx squared plus bx plus c is 1x squared plus 4x's minus 21. Okay, and exactly the same as I got from the polynomial long division. Okay, so what next? Right, so we can say now that f of x is x minus 2, there's our factor, multiplied by this quadratic, by whichever technique you used. And then finally, all we need to do is say, does this factorize? And in this case, you can probably do it by inspection. You might be able to say that x plus 7 and x minus 3 are the different factors there. If you couldn't spot that, you could just use the quadratic formula to find the roots and then substitute those in. Okay, so this is it, fully factorized. So the cubic is x minus 2, x plus 7, x minus 3. Therefore, the roots of that polynomial, if you needed to find those, are x is equal to 2, x is equal to minus 7, or x is equal to 3. And you could just check those. You could, if you work out the function with, so if you work out f of minus 7 or f of 3, you should find that those are equal to 0 as well. Okay, so that's just a quick run through of how you might use the factor theorem to factorize a cubic equation.